So let's try open this laptop. It is not charging and is not coming on. Yeah, just like that. Let's disconnect this ribbon cables and it's out. Not that bad. Okay, let's try and see where's the charging port. Charging port is here. And we have nothing here actually to measure. I'm suspecting it is not charging on, and this LED is not coming on because some voltages aren't present. But it is consuming 10 milliamps and trying to come on, then give up on trying. So no white or red light is here present. So let's see. We have to find some MOSFETs to measure actually the input and to find the charging circuitry. So assuming this is on the bottom of the main board, because I can't see any input circuitry. Okay. So I took out the motherboard. Let's connect it to our bench supply, bench power supply. Let's see, what are these? I'm assuming this is a minus and this is a plus. Okay. And this is our jack. Let me see if it's right, otherwise we're going to short it even more. Okay, let's check. Power on. Okay. Yeah, this is original HP connector. The inside is plus and outside is minus. So yeah, that's right. That's correct. So we are going to plug this here and see on our bench what is happening. And it's taking 1 milliamp. Trying to switch on and then give up trying. 1 milliamp. It's too. It's absolutely nothing. It's kind of be. It should be 9, 10. So maybe we have this short circuitry here. Maybe broken MOSFET, input MOSFET. I mean, let's try and see another time. Another one. 1 milliamp. And nothing. Turn it off. Turn it on again. And it's not even trying to do anything. Okay. Now let's find our main voltage, input voltage. I mean, we are going to see if it's passing those tracks and coming on the coils, maybe drains of the MOSFETs. There is a capacitor. I'm assuming this is the one. If I got it right. And we have plus, minus. Okay, let's see what voltage is here. Oh, there's no voltage on this input capacitor, like at all. Let me switch to another. So let's proceed. I was familiarizing myself with the schematic. There are a bunch of them on the bad caps site, and people are sharing with the schematics. I mean, this is not the razor edge technology. It's like here we can see the 14 number. So assuming this is 14 year, like 10 years ago. So let's proceed. I want to see if the main supply voltages are coming on, like standby voltages, 3 volt and 5 volt. So let's see. Plugging on. You're right, 19 volt. It's taking like 1 milliamp. There is some readings that is trying to start up or something. And suddenly it's like 180 or 60 milliamps, like periodically, like cycling in the loop or something. So let's check. Have a ground here, maybe here. Let's see what this coil is outputting. Nothing. Okay, that's okay. And this one, and this one. Nothing. That's cool, because after turning the actually pushing the power on button, those voltages are coming on, and there is going to be then LDO voltage, like startup voltage for AC chip. AC chip is on the side, like on the bottom of this board. So that one and that one is 3 and 5 volts, that chip and that chip. We should actually check voltage on these capacitors if the LDO is present. So let's check this one. Nothing. No readings. This one. Nothing. Okay. How about this? And again, nothing. Maybe this one. Like 0. And we have no readings. There is 1 milliamp. Nothing here. 1 milliamp. Less than 1 milliamp. like microamps. Okay. So there is no LDO voltages, but it should be at least one, like 3 or 5, because something is consuming it. Okay, let's start over. 1 milliamp. Let's try to find it. Like how? Okay, that's this capacitor. Nothing. This capacitor. Nothing. This. I assume this capacitor. Nothing. And this nothing. And this ground. No. Oh, maybe these capacitors are shorted because the readings are okay, let's see. Let's unplug this and go with okay, let it be the continuity test. No, no, and no. And this. Oh, we have 9 ohm. And again. And again. So I'm assuming this is a faulty one. Okay, let's pause for a moment. So let's see the basic voltages on the main board, like if it's present or not, and stuff like that. Plugging on the charger, starting. Let's see if the main power rail reaching those 2 chips, because those chips are basically the standby voltages 3 and 5. Okay, let's see. The power comes from this chip. We have 19 volt. Okay, so it's coming from this chip, this MOSFET. I'm assuming this is P-channel MOSFET, and reaches where? It looks like some pumping, like 2. Then should be another MOSFET, like maybe this. Yeah, right. Big MOSFET, and power rail reaching here. Let's check voltages on the gate. And there is none. And here, of course, nothing. Let's check voltages here. Maybe this is not our problem. Maybe something. Maybe this is not the issue. Let's check about here. Oh, this is ground. No. No voltages. Here and here. Oh no, this is ground. No. Same situation. So there is no let's say standby voltages. Okay. So, what we learned from this main board by now, that there is some low impedance, like 8 or 6 ohms on the main power rail to the ground. Let's check once again. And that got me thinking, what would possibly causing this? So this MOSFET, this particular MOSFET, it is turning on by the power management IC. I believe it's some BQ something chip. He's powering this MOSFET, and the main power rail appears on the board. So we should check for the source pin of this MOSFET to the ground, and we should have like 9.35 ohm. That's bad. Something is wrong. What is wrong? So actually any MOSFET, any transistor of the high side can be broken, like the CPU, nose bridge, and graphics adapter, graphics chip could be burned out. So let's see. Let's check for the nose bridge. Basically we have to check for the resistance on each MOSFET. What we have here, you can see 8, 9, 10. 10 is good. 10 something is good actually. Another one is here. We are checking apparently the North Bridge. Maybe I'm wrong, but whatever. We are checking drain to the source resistance. If it's short, it will be no O0, 0, like short. And again 20, almost 20, 19.6. Let me check another pin. Yeah, 19. That's okay, 19 okay. And the last one is under the tube, this tube. How could I manage this? Kind of like that. And what do we have here? 10 on. That's good. So this. But before we were checking just the output. So the output wasn't shorted. Output of any coil, any other coil to the ground, and it was okay. So that's the turn for the GPU. Let's say this one. Fourth is gate. We are not checking the gate, just this. And what do we have? It's definitely a short, like 0.00. This one. Okay, that's pretty bad because it's high side MOSFET and it's shorted. So actually the main power rail goes straight to the GPU, but GPU has like absolutely mad low resistance to the ground. So maybe it's that. Maybe not. Who knows? 5, 7, 8, 9, 8.9, 8 point. That's good. This MOSFET is good. This one. And again. This one. What's with this one? It's broken too? Like two? Maybe they are paralleled. No matter. We just can blow them all out with hot air and see what's... the next is the CPU MOSFETs. And I only hope they survived. Because this motherboard can go with dedicated or integrated graphics. Or both. Like switching graphics capability. And 30. Very good. That's what I was hoping for. This 30. Very good. And this? 37. So, what do we know by now? The GPU may be dead, so we blowing these MOSFETs away. Okay, let's proceed. Let me get the hot air. Like 350 degrees. That is. And I still don't have the tweezers. Let's go with this. So we blowing off these two. Okay, let's go. Let me just that's just for the safety, so anything won't burn. And it's out. That's good. Another one. That's good. Not bad at all. Let it cool down for a second. And we are going to check. Not bad at all, I must say. Didn't burn anything, especially this mini PCI slot. Okay, let's wait for a second. Minute. Yeah, it's hot. Let me pause for a minute. And we're back. So let's check these MOSFETs if it's any change. This one is done. How about this? I think they were on a parallel mode of some kind. That one good? That's very good. That one still good. I don't know, I should hide him when I... So, and the main part, let's check for the continuity on the board. Maybe something else wrong. And nothing is wrong. Here. All good. We're good to go. There is actually one step we have to make, is to replace somewhere, I guess here, like this is like an option if you choose to use the GPU or the CPU as a graphics adapter or both. You should move one of those resistors, like, let's start with, I don't know, let me check once again. I'm going to pause and we're back again. Let's hope for the best. So I managed to find which resistors should we move actually to enable the integrated graphics in this in the CPU by disabling the discrete graphics. But actually we have to check if we succeeded and if the lights going on, lights on, because if it's lights on, then the EC chip enhanced controller, this one, is working and bringing the system ready to power on. So let's go and check. Plugging on. Trying not to burn anything in the middle of the process. Checking if we have left any residue. It's none. Okay, let's test. Turning power on, and it's taking 12 milliamperes. I think, yeah, everything is good. 5 milliampere, 6. Light is on, system ready to run. Whew, that's good. Good news. So I'm going to check if the GPU is fine by placing here the working MOSFETs. I have very cool graphics adapter. It's from late 2007. It's GeForce 8800, like the top model of these days, of those days. So I'm going to use these MOSFETs This kind of cool MOSFETs, its on-state resistance is extremely low, like 3 milliohm, and they're absolutely capable to change to our board, to be placed on our board, because of all the parameters are good. So let's do this. So removed some, tested and removed these MOSFETs. Oh, that's okay. Like good old new MOSFETs. So we have to place them accordingly. Placing done, and we're going to hot air them. They're just going to sit with the flux. Is going to sit straight to the pins, to the pots. Okay, 350. That's what I'm going to make myself some space. Okay, let's go. Nothing, no. There's nothing to see. That one moved. That's totally okay. Another one moved. That's okay. And it's done. Another one. Obviously we don't need the microscope. These are big ones. I don't want them to move like this. I don't like it. I think it's okay. Maybe not. Let me see. It's too much. Oh, it's more like it. Okay. I don't think it's going to fall off. But who knows? There is no other options than to check it by yourself. Okay, let me apply some alcohol just to clean it. Okay. I think everything is all right. Like visually, I see if. Okay, let's test it. If everything is okay, let's test it. How we are going? Are we going to test it? Oh, let me just apply this here. I almost forgot about this ZVS diet. Zen diet. One side, another side. It's going to be fine. Okay. I'm assuming everything is okay. So let's check. The continuous check. Actually, you can apply like resistance check, resistance mod, and we're doing the same. Not bad. It's gone. Everything is going to be okay so far, and so I'm going to put it in the notebook case, the laptop actually, assemble it again and start. So I finished the assembling. Test assembling actually, because if you want to succeed, the moment of truth. Let's have a look. Is it going to start or what? I will increase like to 3 amps, and let's go. So far everything is fine. Let's start. The fan is spinning, and we have picture. Look, look, look. That's crazy. Actually working fine. Everything is good. The graphic card is working. It's not toasted. I think. There was no beeping. Everything cool. It's taking like 2 amp, 37. Look fine? Okay. That's a win-win. See ya.